Before we start, if you haven't seen episode 1, perhaps go back and watch it. I'll put a link in the description. In this second episode, we're going to be looking at answering some of the big questions that we had at the end of that first episode. We're going to see what impact a nozzle has on actual prints, and what kind of nozzle faults cause terrible prints, and what nozzle wear even is, and why any of this matters at all, if indeed it does. And also why I paid £7, which is about $10, for this. I'm still not sure about that myself. Let's go. This episode is sponsored by PCBWay. In order to test effectively, I need to eliminate as many variables as possible, and that needs a consistent platform that I can use to test all nozzles, and that is why today I'm using the Prusa Mark IV. Nearly all the nozzles I have to test with today are the cheap and freely available V6 type, which is one of the oldest types of 3D printer nozzle, and the Prusa Mark IV is one of exactly 2 printers that I still own that's still compatible with these V6 nozzles. Not natively out of the box, the standard Prusa Mark IV nozzle in fact looks like this, but you can buy this adapter online that forms the rear half of this nozzle assembly, and then the front half becomes a V6 nozzle. In a moment we'll actually test whether that affects prints too. So, how do you test nozzles exactly? This is the question I struggled with for most of this episode, and this is also one of the reasons why this episode took so long to release. You tend to find that videos like this one, they go on a journey and you don't always know where that journey is going to end when you start, because sometimes the question changes as you realise that what you were originally asking is a different question. You can stare at a nozzle all day long, and trust me, I have, but you don't get the answer. You have to print with that nozzle and somehow qualitatively analyse that print. Ultimately, I chose 4 prints that cover all the qualities I consider important for printing. One of them I had to design myself. I wanted to try to figure out whether some nozzles work better at some line widths, so I designed this part here. It looks funny because I made it as a square, but then I realised I don't need most of the square, so I cut the piece down. This is a clever test, if I can blow my own trumpet. It allows us to print all line widths between 0.2mm, which is the smallest nozzle size, and 1mm in one single print. This is possible because of the Arachne slicing engine, which was originally in Cura. If it's given the right parameters, it can vary the possible line widths. So we're kind of exploiting some functionality that the slicer already has to turn it into a test. I did a video on Arachne a couple of years ago if you want to know more about that. So the big question with these nozzles, is there actually a difference? Well, I'll let you judge that. Personally, I think no. Not really. The other interesting thing is that there's no difference I can see between the Prusa and the V6 nozzle. In some ways, it's not that interesting, as the changes made to the Prusa nozzle were aimed at ease of swapping, and also the long tube that the Prusa nozzle has that the V6 nozzle doesn't means that the filament is constrained all the way back to being completely cold, where the extruder is. So if there's no difference here between these three nozzles, then what about if we look at other sizes? If you did watch the last episode, you will remember this particular nozzle. If you're thinking, this isn't 0.2 millimeters, it's supposed to be, but it's not 0.2 millimeters by quite a long way, you would be correct with that assumption. But how do you measure that? Well, I was at E3D a short time ago, and while I was there, I asked them how they measured their nozzles, and they were kind enough to show me the process. They have some very fancy machines that can give exact dimensions, and they are extremely capable at getting very good answers to how big the hole in a nozzle is, because they've got the machinery to do it. Now, I don't know about you, but I don't have one of these fancy machines. They are ridiculously expensive. Instead of accurately measuring a nozzle, there is one reasonably ballpark accurate to within maybe 10%, which honestly isn't that accurate way of doing it here with the kit I have. It's better than nothing. And yes, we are going to look at my photo gear again because you all enjoyed doing it last time. This is an Astra Hori 2x to 5x high magnification macro lens, and it's a copy of another one, but it is actually brand new, so this is the first time you'll see this, probably. I'm sure you'll see it on all the other 3D printing channels shortly, maybe. I didn't have this for episode 1, so this is partly why we're seeing better images overall in this episode, but not the whole reason, as you'll see in a minute. The interesting thing about lenses like this is they are fixed focal length. A normal lens has a ring on the end that you turn to focus. I'm sure if you've ever used a camera, you'll know that you have a thing called focusing. But these lenses, and also they share that in common with microscope objectives, which is the other thing I've been using, they don't have focus rings, so to focus these things, you have to move them back and forth until they're in focus. So that means that if you set this lens to 5x magnification and something is in focus on the screen, then it's guaranteed to be an exact distance from the camera sensor, and that will never change. This means that it will always show things at the same scale, which means it will always show things on the sensor at the same size. And this means that if you can find any object that you own that has a known size, then you can take a picture of that and you can work out how many pixels that takes up on your image, and then you can use that to measure other objects with a reasonable accuracy. So from this and the edge of a depth gauge, I can tell you that this 0.25mm Prusa nozzle is around 0.28mm, which is fine. And I can tell you that this, I think it's an E3D 0.4mm nozzle, is in fact around 0.38mm, and that's fine. And this E3D 0.5mm nozzle is showing as 0.52. And that's fine. And I should note that there is, I already said it, there is some intrinsic error in the way I'm measuring. So these are probably all spot on the sizes they should be, or as much as we can know. And this Diamondback 1mm is coming out at 1.095, and I imagine that that is probably the most accurate one out of all of them, just because of what I know about the way Diamondback nozzles are made. So you can kind of see the kind of error margin we're probably looking at. It's about 10%, as I already said, but it kind of doesn't matter, because this 0.2mm nozzle we were just questioning is reading at just over half the size it should be, and that is way out. And the shape is not circular at all either. So yes, this nozzle is definitely not a 0.2 nozzle. We were correct, and we could judge that by eye, in fact, if you have decent vision. Oh, and that's also what this thing is as well, by the way. This 7-pound piece of steel is 0.4mm. It's exactly 0.4mm. That's the intention. So assuming that that is correct and I haven't been ripped off, then I could also use this to calibrate the sizing on the camera if I'd had it in time, which I didn't. But I'll use it for next episode. For some reason, 0.2mm nozzles seem to be a huge problem to manufacture, because in my tests these were the ones that were most often furthest from accurate, and they were also the most gnarly looking. The question is, does it matter in the print? We know that this nozzle is way off where it should be, but let's look. I'm going to say yes this time. It's not as bad as you might have expected, The problem is probably most likely the result of under-extrusion because of poor pressure management, because the hole size is that small. And also you might consider it to be damaged. This leads us on to the second part of the video, damaged nozzles. And the first part of the second part is something I noticed when I was filming the wear on these nozzles, and this part was kind of unexpected. This Prusa nozzle you see here is only a few print hours old, and I noticed some stuff around the edge that looked a bit like metal. What looks like happened is the new nozzle has a lot of loose bits or bits that stick out that they get abraded off very soon after installing the nozzle. I tried replicating this again on an E3D nozzle, and I tried to take better pictures at a better angle so that we could see what was happening. You can see some of the wear here after one print, and then also after 5 hours of printing and after 10 hours of printing. It's not as bad as what we saw on the Prusa nozzle, but you can see there's some bright spots around the corners, which I think represent metal that's been removed. But it's really hard to prove it, because where's the metal gone? You might think it's possible to capture this on a new nozzle if you had slow motion close-up macro footage. And you'd be right. I don't know about you, but I think this makes me think twice about using new brass nozzles for things that are in contact with food. You might not know that brass usually contains about 1 to 2% lead. That's assuming you actually wanted to eat brass in the first place, although it is encapsulated in the plastic, and the amount of lead is not normally considered a huge risk because it's an amalgam, I think, with the brass itself. I'm not a metallurgist. I didn't really investigate how long this kind of thing continues. It will slow down pretty soon, I expect. It's not got an infinite amount of metal to put out into the print, so probably not more than a few hours, I would guess. Whether you're bothered about this is up to you. Definitely run a bit of filament out before you print anything that you're going to use for anything to do with food. I thought it was mostly just really fascinating. But also, above all else, I think it kind of indicates that any kind of anomaly on the face of the nozzle or even in the bore is just not going to last that long, because it's going to be in your print if it's in the way. I think a lot of us did this as kids, but some of us never really grew up. The point I'm trying to make here is that, logically speaking, nozzle aperture shape would affect the extrudate. The question is, does it affect the print? There's two ways that come to mind in which you can look at this. You can either print a model and just look at the model, you could even magnify it and you could look at the top surface, or you could print one single layer and just look at that top down. To test this, I damaged 2 nozzles, and then I damaged 3 more, probably just out of spite. It's actually pretty easy to damage nozzles. The first 2 were just cut with snippers, the ones that come with a printer. One nozzle ended up with a groove in it, and the other one I kind of reamed out somewhat, perhaps a bit much. Now, you're probably not wondering how I took better macro pics of the fronts of the nozzles compared to last video. Probably because in this episode the macro pics are frankly perfect, and I think a lot of the improvements are in my process. I have to spend less time trying to sort the light out, and the reason for this is because of this episode's sponsor, PCBWay. The thing you see on the front of the lens here is a light ring that I designed to my specifications in terms of size and light colour and voltage, and so I picked out some LEDs that were 5000 Kelvin in colour temperature because, slightly techie info, but that is what I film at in the studio as standard. so I wanted the lights to match all the other lights that I use. I designed the PCB in Fusion 360, but you can design it any way you like. You can use any software you want. Here is a render of it, and all you have to do is send the Gerber files with some other files that tell PCBWay where to actually place the components. This is the extra step you need to get the assembly. Your PCB software gives you all of these files, or should, and then using PCBWay's assembly service, all I had to do was, well, nothing. Just sit back and wait for them to do it all for me. I assure you, if I was trying to solder these components with my fat fingers, I would have made a huge mess, and perhaps I can show you that at some point, because I've got some blank ones as well. But yeah, I've tried it before, and no, I'm rubbish at surface mount components soldering. So how about that? Actually using the video sponsor to make a thing that actually materially makes the video better. If you want to get a PCB assembled like I have, then PCBWay can do it for you, and it's surprisingly easy, as evidenced by the fact that I managed it, and I did it first time successfully with zero prior experience. Obviously my PCB isn't the most complicated, but if you've got the experience, yours can be, and it doesn't have to be. So go check out PCBWay using the links below in the description and take literally all the hassle out of the PCB making process, and potentially also even the component soldering part too. Thank you PCBWay for sponsoring this video, and let's have a look at what those mangled nozzle extrusions look like. So the first nozzle, the one with the groove in, it doesn't perform badly, I don't think, but you can see the groove in the top of the extruded line, so it does have an effect. The significantly reamed nozzle, though, is another story, but we'll get into why that's potentially a lot worse in a moment. The second batch of nozzles I attacked with a file and a saw, so we ended up with Groovy, Big Hole and Tilty, and yeah, I guess we're naming them now. I thought a tilt in the tip of the nozzle would be interesting because it would mean that the extrudate gets shaped into a wedge, and it will change depending on the direction the nozzle is travelling. And yeah, it's even weirder than that in reality, because you get some really strange bubbles in there, and I have no idea how that happens. But it's less than ideal, I will say. I don't think that's going to give a good result. The Groovy one doesn't do too bad. Again, it seems like having these sort of grooves in the top of the nozzle, and that's something we do see when we buy nozzles. Some of the examples I've got tiny little grooves in the top because they just mash together in shipping, I think. But that doesn't seem to have a massive effect. But the nozzle with the big hole in is a disaster. Why? Well, it's got a big hole in it. It's the most uniform of all the nozzles though, so you would expect that to give the best result, even if the hole is too big. All I did really was simulate wear. Wear on nozzles is a pain to replicate for a video because of the amount of time that you would have to run a printer for and the amount of filament you'd have to waste, and I'm not really willing to waste that much filament just to prove a point. It's easy enough to simulate for a video because that's what I've done here. If you consider wear to be caused by exactly two factors, firstly the scraping of the flat part of the nozzle against the top of the print as it's printing, or perhaps the bed if you're into that kind of thing. We do try not to. And the second is the widening of the center hole just through the amount of material that's passed through it. Both of these effects eventually end up in the same place. This place. A worn nozzle, arguably then, is just a wider nozzle. If I take big hole and I measure it, we are at about 1.1 millimeter. It's not very uniform, so it's hard to give an exact number. Now, if I tell the printer that this is a 1.2 millimeter nozzle and I slice a file for that size, that's a big nozzle. But when I print it, it suddenly seems like a working nozzle again. You probably would get the same result if you actually bought a 1.2 millimeter nozzle. So here you go. Perhaps you might rethink throwing old nozzles away. It seems like maybe they have their uses. Again, if nothing else, this is interesting. I'm going to go as far as to speculate that one of the biggest issues with cheap nozzles is probably the hole sizing. It's probably the one thing that matters. So we have to somehow come to a conclusion based on everything we've found in this episode, I guess. Firstly, I think for me, I feel like cheap nozzles, at least the ones that I have here, and I bought a lot of nozzles. I've seriously looked at a lot of cheap 0.4 nozzles. I think the 0.4 size ones are actually mostly okay, especially if you're using line widths that are wider than the nozzle, which Prusa Slicer does as standard. I think it uses 0.45 on a 0.4 nozzle, so this will compensate for any minor hole tolerances. And as we've seen with the line width tests, too small holes aren't really so big an issue, up to a point. Obviously, half the size they're supposed to be is probably pushing that. But I didn't see that with any 0.4 nozzles. There are also plenty of footnotes with the above statement that we might get into in the next episode, which is, by the way, going to be an unapologetic diamond back nozzle episode. We're going to go into the thermal properties of the materials and the implications on flow rate. And, of course, if you do have a smaller hole in your nozzle than it should be, then this will have implications on the maximum flow rate that that nozzle can do, and that could ruin prints if you are printing especially fast or at a high flow rate. I didn't really have time to go into that into this episode, so hopefully we'll catch up on that later. Also, I think we learned a lot about initial wear of a nozzle, what you might call a bedding in process that I had no idea existed. I would have probably expected something, but nowhere near what we saw. That was weird, honestly. And finally, the shape of a nozzle has some effect on the actual shape of the top of the extrudate, as you would expect, but as you wouldn't expect, it's really not a huge factor in the overall print most of the time, as long as the overall hole area is not significantly different to the spec. That is, that you haven't gone at it with a pair of clippers. So there you go. I hope you found that interesting. Make sure you're subscribed if you want to see the next episode, where we're going to go into Diamondback and maybe CHT, or that might be another episode after that. We'll have to see. Anyway, I will see you next time. Thank you for watching.